Hello everyone, Mr. Minix, my name, math is my game. Today in Algebra 2, what we're looking at is a lesson that it's probably the easiest lesson we're going to have all year, aside from simplifying radicals. The title of today's lesson, it's Solving Quadratic Equations Using the Technique or Method of Taking Square Roots. Sounds pretty easy, and it is. 4.6, we're going to be completing the square, but we're not quite ready for that yet. So 4.6, part 1 of 3, solving quadratic equations by taking square roots. I mentioned to my class before we started, the big takeaway is simplifying square roots. One other big takeaway is to remember, to keep in the back of your mind, whenever we solve a quadratic equation, to think to yourself, quadratic equations have how many answers? How many solutions do they have? They always have 2. Okay, they always have 2. So example 1, a lot of people miss this. It's a real easy question, but a lot of people miss it. If they tried factoring it, they'd get it right. I didn't say how to solve it. I just said solve it. So by taking square roots, by square roots, we're just going to square root that. We'll square root that, and we think that x equals 7, and we're done. The problem with doing that is we miss half the problem. How do you get negative 7? Negative 7's right, and 7, but how do you know that it's negative 7 also? Because it's the opposite, but how do you know that it's the answer? Yeah. Oh, because it makes the equation true. Negative 7 times negative 7 equals 49 also. Yeah. So here's the deal. Here's what you ought to think to yourself. Here's what you ought to make a note of. Whenever you take a square root, solving quadratics, you always use a plus or minus. Okay? Always use that plus or minus. Anytime you take a square root with a quadratic, you always want to include a plus or minus in your answer. So rather than writing x equals just 7, x equals plus or minus 7. Okay. The second you introduce a square root sign when you're solving a quadratic equation, you want to have a plus or minus the next step. So to make that real clear, in this step right here, we did the square root. The very next step, make sure you got that plus or minus. Okay. Real important. Because without that, you only have half the answer. Right? Any questions, comments, concerns, short or long debates about the first example? If not, let's go right on to example 2 then. Example 2, we're going to solve x squared minus 20 equals 0. And I'll go ahead and finish the directions by taking square roots. By taking square roots. So I guess when we go to solve this by taking square roots, in the past we liked to have it equal to 0. But when we solve by taking square roots, we don't want to have it equal to 0. So I guess we're going to have to, add 20 to both sides. So we get x squared is equal to 20. Okay. So what should we do next? Take the square root, try to take the square root. I like that answer. So we try to take the square root, and we think that x is equal to plus or minus something. And you probably get a calculator out, you punch in rad 20, and you get 4 point something. Well, I got news for you. 4 point something is an answer, but it's not the answer we're after. In Algebra 2, we like to find what's known as exact answers. Okay? In Algebra 2, we like exact. We like to be exact or precise. In exact, the second you punch it into a graphing calculator or any other calculator and it gives you 4 point something, you're no longer exact. That's an approximate answer. Okay, x is approximately plus or minus 4 point something. But we want an exact answer. X is exactly plus or minus something. So let me see what that 4 point whatever was. Square root of 20. Square root of 20 is 4.47. Okay, that's an approximate answer. In Algebra 1, that would have been okay. In science class, that's okay. But in Algebra 2, guess what? It's not going to get it done. Now, if you just wrote that your answer is exactly plus or minus the square root of 20, and you circled that, that's okay, but it's not good enough. On an upcoming test or quiz, that'll get you -1, because I expect you to be able to simplify this. Okay. So does anybody think they know what the answer is in simplest radical form? Don't have to put it in a fraction, but you do have to break apart the radical and simplify the square root. Anybody remember doing that? Know what our best answer is going to be? What our best answer is? Yeah. 2 over the square root of 5? Not quite, but you're onto something. It's 2 times the square root of 5. And yeah, plus or minus 2, so x equals plus or minus 2 times the square root of 5. That's it. That's it. Nice. Awesome. So in case you're thinking to yourself, how on earth did we come up with that? Here's a little crash course in simplifying radicals. Simplifying radicals means there are no perfect square factors. There are no perfect square factors larger than 1 under the radical. When you simplify a radical, it means that there are no perfect square factors larger than 1 under the radical. So in the case of the square root of 20, if we think about 20's factors for a minute, 20's factors, of course it's 1 and 20, and of course it's 2 and 10, and of course it's 4 and 5. And if we look at 20's factors, unfortunately one of them, this 4 right here, that's a big perfect square. That's a perfect square bigger than 1. And because of that, the square root of 20 is not simplified. Okay, the square root of 20 is not simplified. Okay, because of that 4. Now, you might think to yourself, well, does this happen with even? All right, so we didn't miss a beat here. Here we go. So you might think to yourself, well, does this happen with even numbers? No, it doesn't. It has nothing to do with even numbers. Let's look at the square root of 42. Let's look at the square root of 42. If you look at 42, 42's factors are 1 and 42 and 2 and 21 and 3 and 14 and 4 doesn't go into it, 5 doesn't, and 6 and 7. Okay. So when we look at the square root of 42, do we see any perfect square factors that are bigger than 1? Are there any perfect squares in there that are bigger than 1? 2's not a perfect square, 3's not a perfect square, 6, 7, and 14, none of those are perfect squares. So the deal is the square root of 42 is simplified. The square root of 42 is simplified. Okay? That one is already simplified. There's nothing to do. So when we simplify these radicals, here's kind of like the fast way to simplify radicals. Fast way to simplify radicals. Fast way to simplify radicals. Find the factors of the radicand. That include the largest perfect square. The largest perfect square. I know this is a lot of writing. Good thing it's a Monday. So we're going to find the factors of the radicand that include, that should say that include, not that incline. The perfect square that include the largest perfect square. square. There we go. So we're going to find factors of the radicand that include the largest perfect SAR. So when we tried to simplify the square root of 20, we broke 20 down into 1 and 20, 2 and 10, 4 and 5. And we're looking for perfect squares, and 4 is the perfect square. And 4 and 5 are that combination. So we find the factors of the radicand that include the largest perfect square. In the case of 20, there's only one number that has a perfect square bigger than 1. And what we do then, this is the fast way to simplify radicals. What we do then is the square root of the perfect square factor pops out. I'm putting that in quotations. When I say pops out, I mean we know what the square root of the perfect square factor is. That's why we pick it. That's why we pick it. So the square root of the perfect square factor, not the perfect square rotor. Wow. The square root of the perfect square factor pops out. So what our answer is going to look like, this. What is the square root of 4? 2. So what that means is we're going to have a 2 that's going to pop out. We're going to have a radical left behind. And remember, this is like the straight to it, the fast way to simplify radicals. Then the final thing is the other factor. The other factor remains under the radical sign. The other factor is going to remain under the radical sign. The other factor remains under the radical sign. The other factor remains under the radical sign. So the other factor in this case, we used 4. The other factor is 5. So we end up with 2 rad 5. So when we factored, you had to find factors of a number. When you simplify radicals, you have to find factors of a number. Finding factors of a number is a very important skill in advanced math. Knowing your perfect squares is also important, right? Just in case you forgot your perfect squares, of course, they're 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. I always forget 13 squared. It's 1 something. You said it, I didn't. 169, and then 196, and then 225, 256, 289, 324, 361, 400. Some other notable ones are going to be some other notable ones. Oh, my smartboard doesn't like me today. 900 is a perfect square. Yep, it's going to be a long day. 900 is a perfect square, so 1600. I think 676 is too, but that's a good list to start with. So let's just try a couple more simplifying radicals. Let's try to simplify the square root of 48, see if we could do that. So we're going to need to know 48's factors. 1 and 48, 2 and 24. Remember, we're looking for perfect squares. We're looking for perfect squares. One's one of them. 48's divisible by 4, isn't it? 4 and 12. 4 is a perfect square. But what did the little fast way I mentioned earlier say? Remember the very first bullet point? There's something important in that first bullet point. The first bullet point said, find the factors of the radicand. That means the number under the square root. Find the factors of that number under the square root that include the what? The largest. The largest. That's real important. I wouldn't have put it there if it wasn't important. That include the largest perfect square. So we're going to keep finding 48's factors. 48, 4 plus 8 is 12, and 12 is divisible by 3. So guess what? 48 is divisible by 3, right? 3 goes into 48. That's 1, that's 3, that's 1, that's 8. Oh, 3 and 16. 3 and 16. And guess what? 16 is a perfect square, isn't it? So which is the biggest perfect square factor of it? 16. Okay, the 6 and the 8 really don't even matter. So the deal is we're going to use these two. So when we simplify the square root of 48, we said that the square root of the perfect square factor pops out. So what pops out? The square root of the perfect square factor. So the square root of the perfect square factor. So here's our perfect square factor, the 16. And its square root's going to pop out, so a 4 is going to pop out. And then the other factor just hangs out under the radical. So what's under the radical then? 3. So 4 rad 3 is our answer. How we doing? Good? Make sense? I hope so. One other thing about simplifying radicals, there's this property that says if you have a fraction of radicals, that you can split it up like this. Okay, so suppose you had something like the square root of 4/9. That's the square root of 4 over the square root of 9, and that would be 2/3. Okay, we're going to see something like that. So if you take the square root of a fraction, it's the square root of the top over the square root of the bottom. You can split them apart like that. So far, so good? Awesome sauce. I wonder what kind of sauce is awesome. Barbecue? What kind of sauce? Sweet Baby Ray's? That's good. Which flavor? The original or the... Okay, I kind of like the brown sugar. Bacon ranch, that's always good. I have about 6 different ranch dressings at my house at any time. Yeah. Not a fan of the buttermilk, though. All right, example 3. This one's not bad. We want to get x by itself. So before we can get x by itself, I guess we got to get rid of this 1/2, don't we? So what do we do? Divide both sides by a half. Okay, so 1/2 divided by a 1/2 is going to leave x squared on the left. But I don't know how to divide 4 by a half. It's the same thing as multiplying it by its when you divide by a fraction, didn't we talk about this a couple weeks ago? Yeah, it's going to increase in size. So when we divide by a fraction, we multiply by its reciprocal, right? So we're going to multiply by 2 over 1. So we get x squared equals, what's 4 times 2 over 1? 8. So x squared is equal to 8. Now we're ready to take square roots. So I guess we just got to take the square root of both sides now. Squared x squared's x. I'm taking a square root with a quadratic. What should I do when I take the square root with a quadratic? When I take the square root of a quadratic, I got to remember to, let's go back and look at our thought bubbles. The second I introduce a square root with the radical, I guess I better put that plus or minus sign, right? Don't want to forget that. That's important. So I don't want to forget that plus or minus sign. So this is going to equal plus or minus something. Now we're not in 9th grade anymore. We're not in 8th grade anymore. This is varsity math. We got to simplify that rad 8. We got to simplify rad 8. So 8's factors are 1 and 8 and 2 and 4. What's our biggest perfect square factor there? 4. 4 is our biggest, so we're going with the 2 and the 4. So the square root of the 4 pops out. So what pops out? 4's square root pops out, so it's going to be a 2 that pops out. And that 2 ends up being the square root of this, right? The square root of 4, that's where that 2 comes from. And then what's under the radical then? I guess I already gave it away. It's 2. And to be clear, this 2 is what's under this radical, right? So that's it. X equals plus or minus 2 rad 2. X equals plus or minus 2 rad 2. How do we feel about that, all right? Pretty good? Questions? Comments? Well, it's not going to get that much more difficult. We got a total of 6 examples to get to, and let's look at the next one. Ooh. Ooh. Oh, man. 25x squared minus 6 equals 30. So when I solve quadratic when I solve equations, I'm doing PEMDAS. in the inverse order, so I guess I'm going to do sad map. So is there any addition or subtraction to do? Add the 6 on both sides. You got it. So 25x squared is equal to 36. So our addition and subtraction's done. Any division or multiplication? Divide 25 on both sides. All right. So we get x squared is equal to 36 over 25. So our division and multiplication's all done. Now we just got to handle that exponent. Ooh, taking a square root. Square root, square root. So x is going to equal plus or minus. And how do we do? Can we split that up then? I heard a 6 over 5. Because this is the square root of 36 over the square root of 25. So our best answer is plus or minus 6 over 5. I don't know why some people like to bring the radicals with them. But I want to make it as clear as I possibly can that when you take the square root of 36, that's equal to just 6, right? So when you go from here to here, there's no need for a radical. And a real common mistake, I've been at this for 20 years, I see people rewriting the radical. You know, if something's a perfect square, the radical ends up going away. Does that make sense? All right, so cool. Well, we're almost there. Example 5, it looks like we've got some of this. Sometimes that's a bad thing, but in this case, it's a good thing. That 2-letter acronym is a binomial squared. Binomial squared. That's a good thing. It's a very good thing. The square of a binomial is a good thing. It's awesome. You know what's so awesome about a binomial squared? It's what? It's already squared, and because it's already squared, there's something we can do to it. We don't want to multiply it. It's actually counterproductive to multiply that thing out. I'm hearing subtract. I wouldn't subtract it. It's counterproductive to subtract it. If we, in the event of the last 4 examples, we had something squared and we took a square root, right? Had something squared, we took a square root. Our first couple of examples, we had something squared, we took a square root. So what's so nice about a binomial squared, do you think? We're not going to square it. We're going to actually just take a square root. Here's the deal. The square root of a binomial squared is just the binomial, right? You picking up what I'm putting down here? So the deal is I've got this x minus 3. It's a binomial squared. It's equal to 12. What I'm going to do is I'm just going to go ahead and take the square root of the binomial squared. So what's the square root of x minus 3 squared going to equal? Well, here's the deal. This radical here and this exponent of 2 here, those are inverse operations to each other. It's not just 3. It's going to be x minus 3, right? And then whatever I do to one side of the equation, I got to do the same thing to the other side. So I take the square root of 12. So I'm going to take the square root of 12. So I guess I better know how to simplify the square root of 12. 1 and 12, 2 and 6, 3 and 4. What's our biggest perfect square factor? 2 and not the 2 and the 6. Isn't 4 my perfect square? So I'll go with the 3 and the 4. So what's that going to equal? 2 rad 3. Good. That's going to equal 2 rad 3. What am I missing? What did I forget? Plus or minus. Got to have the plus or minus. And we're almost done. We're almost done. PEMDAS. Got the I got to get the x all by itself. So what do I got to do? Add 3 to both sides. So here it is. Here's my answer. X equals positive 3 plus or minus 2 times the square root of 3. And that's it. And that's it. How do we feel about that one? All right. So one thing you might think about is our answers. Our answers now have radicals in them. That means they're not rational. If our answers don't have radicals in them, they're rational. And if we have rational answers, you know what technique would have worked other than taking the square roots? Factoring. If we ever get rational answers, factoring would have worked. So, real quick, I just want to take a sneak peek at this one on a calculator. Insert, graphs, graphs, graphs. So if I graphed that x minus 3, the quantity squared, and then I graphed a line of 12, a line when x equals 12, and then I go to the window, to the wall, and I set my window settings so I can see this. I want to go up to like 15 here. My answers are where those graphs intersect. Menu, analyze graph. I want to find the intersection points. And those things intersect. One of the x values where they intersect is negative 4.64. Now we said that the answer was 3 minus 2 rad 3, which is negative 4.464. If we look at 3 plus 2 rad 3, that ends up being 6.46. And if we find this other point of intersection, I'll bet it's the same thing. Analyze intersection, this other point of intersection, 6.46. There it is. Okay, make sense? Any questions? We got one more example. And this last example is going to set us up for what we're going to do tomorrow. Is everybody okay with example 5? Okay. One thing about example 5 is where to put that 3. I like to drop that 3 off right in front of the plus or minus sign. Okay, that's a really nice place to put it. So, all right, last one. Example 6. Psst. 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 Anybody remember what a psst looks like? Get out the triangle. It's a chevron. Flip it over. Psst. Psst. Remember that? From like 2 weeks ago? It's important. It's real important. Do we have a psst going on the left side of the equation? Perfect square trinomial, do we have one? Is this a perfect square trinomial? It most certainly is. Being able to recognize those is very important. Knowing that those factor into a binomial squared is also very important. What binomial squared is that going to factor into? What is it? It's going to be a 4, and it's going to be an x. And what sign in the middle? A minus. Awesome. So we end up with x minus 4, the quantity squared equals 81. Hey, just like that last one, what do we like about binomial squareds? It's a good thing. Why is it a good thing? Because we can, let me finish this, because we can square root them, right? Because we can square root them, that's why it's a good thing. So what are we going to do with x minus 4 quantity squared? Square root it. We'll take this thing square root, which leaves x minus 4 on the left. We take 81 square root, which is 9. Did we forget something? We took a square root, so what should we introduce? Plus or minus, thank you. So we just need to bring that 4 over, and when we bring that 4 over, then x is going to, should we put the 4 after the 9 or in front of the plus or minus? I like putting it in front of the plus or minus. So x equals 4 plus or minus 9. If we stop there, it's kind of like leaving the groceries in the car. It's kind of like carrying the ball to the 1 yard line and falling to your knees and letting somebody tackle you. That would be silly. We need to take this the rest of the way. We need to take it to the house. So x is going to equal 4 minus 9, and x is going to equal 4 plus 9. Dang it. So what is 4 minus 9? Five, and it's going to be negative, right? So x equals negative 5, and then 4 plus 9? 13. X equals 13. So those are our two answers, negative 5 and positive 9. Okay. Hey, wait a minute. Those answers are rational. Let's look at that example one more time. X squared minus 8x plus 16 equals 81. That could have been x squared minus 8x. What's the difference between 81 and 16? That's a 5. That's 65. Minus 65 equals 0. X minus 13, x plus 5. Couldn't I have factored that? Huh. Interesting. There's always more than one way to the Eastwood Mall, isn't there? Well, I hope it's been educational. I hope everybody has a good idea how to do the homework. Basically, what we just looked at is exactly like the homework. There's two questions in the homework that you should have questions about tomorrow. I won't say anything else about it. I'll just say there's two questions in the homework that you should have questions about tomorrow. So there's like 10 on the front and 4 on the back. They're not too bad. Shouldn't take you real long to do these. So it's been fun. Shout out to all my other classes. Shout out to the future Mr. Minnick. I hope your uveitis gets better. Have a great day. Bye. Good.